Welcome to my talk about my abusive relationship with AngularJS. Is this okay? Can you hear me all? Is this like working well? Okay. Excellent. My name is Mario, and what is going on here? Come on. And I am a researcher and postdoctorate at the Ruhr University in Bochum. I spent my time with client-side security, browser security, JavaScript security. I created a company, and it's a penetration testing company, so we don't give horrible security advice, and we don't sell any products that are nonsense. We just do penetration tests and source code audits and show you where the bugs are, and then you can fix them, and we can have a look at those fixes, and that's a good thing. I wrote some books, wrote a bunch of papers, did a bunch of conference talks, and maintained a bunch of open source projects, one of them being the HTML5 security cheat sheet. Maybe you know it, maybe you don't. It's effectively like a collection of attack vectors that you can use against your website. And I maintain the DOM Purify project, which is a client-only, JavaScript-only, anti-XSS tool that is capable of receiving a string of dirty HTML and giving you only the clean HTML. If you want to follow me on Twitter, which is going to be a very painful thing to do, you can just like try this nick here. Or if you want to send me an email after this presentation, you can do so, and I'm going to read it and I'm going to reply, most likely. So, about this talk. We're going to be talking not about the fancy schmancy stuff that we can see in AngularJS 2.0, but we're going to talk about what everybody is using, which is AngularJS 1.x, and how this framework deals with security. And we're going to wonder, why is this relevant? Like, how does a client-side, like a JavaScript framework, have any impact on security at all? And I can tell you already it has, and I can also tell you already that it's going to be pretty dirty. So this talk is going to be offensive, and it's not nice, and it's not ethically correct, it's not politically correct, it's going to be really, really nasty, and it's going to be technical, so be prepared. The most important question that I'm trying to answer with this talk, and maybe you can answer it for me afterwards, is whether AngularJS is the honey boo boo of JavaScript frameworks. Who here knows honey boo boo? Damn, there goes my narrative. You should look it up. It's pretty amazing, like things people come up with. Not in a good way, it's true. So let's first talk about what AngularJS actually is. Like, I reckon most of you actually know what it is. Like, who doesn't know what AngularJS is? No one, that's good. Maybe, no, I'm not sure if it's good. So it's a pretty popular JavaScript model view controller framework, or actually it's like model view whatever, so you could do a controller or just model view or whatever you like. So it's attempting to be very flexible. And it calls itself a superheroic framework. And if someone goes along and calls themselves superheroic, then you know that there's something fishy. It was maintained by Google. It's not anymore. And it's also recommended by Google, but Google is not the maintainer anymore, at least not of the 1.x branch. It is a fairly polarizing philosophy because it pretty much throws away the pattern of how web applications are to be built that we know from the past, like when grandfather was still building websites and using get parameters. All that stuff is gone. It doesn't use get parameters anymore. It has like completely different data flows that you don't know in classic web applications. And it has an ever-growing user base. So there's more and more websites, even big ones, that are using AngularJS. And there's websites that seem to be like super smart and think like, hey, we have this website already, let's put AngularJS on top and make it even cooler. And that's like a horrible idea. So there's a huge rate of adoption. And if you have a look at the traffic on the GitHub repository, you will soon notice that there's lots of traffic. And that is good for people like this, attackers. We will see soon why that is. Well, it's not the first time that I've been talking about AngularJS, so we have a fairly long past. The first time I was talking about this was when I was doing research on JavaScript model view controller frameworks in general and the security implications. And in terms of security, I quickly realized that AngularJS was the shittiest one. Like, they really messed it up in so many levels, on so many, just like absolutely incredible. So I created a project that was basically an open wiki to document all these issues, document mitigations, and describe other frameworks and compare them. You can find those if you click those links. The slides are public in an older version already and will be public soon, probably on the conference websites. And we had contact with the AngularJS core development team. We had like long fights with them. We had contact with Google's internal security engineering team. We had not so many fights with them because they understood what we wanted. And well, it suddenly boils down to the question, is it like a personal thing, like me wailing on AngularJS? No, it's not personal. It's just like, you will see the reasons. We're gonna explore the reasons why I keep waiting on this framework and think it's a bad idea to use it. So if you Google for AngularJS, you will find this. AngularJS, the superheroic JavaScript model view, whatever framework. So they kind of like themselves a little bit, which I guess is okay. So there's a lot of self-love involved here. They call themselves superheroic. And as mentioned, it changes the ways websites work. Like, it's not that standard stuff anymore where you pass a get parameter in or a bunch of get parameters and then the server gives you something back. It works differently. Interestingly, the AngularJS people break their own API literally all the freaking time and make upgrades harder. So if you're stuck on one particular AngularJS version that is flagged as insecure, you're gonna have a fairly hard time to upgrade your version, and that sucks. But what sucks most with AngularJS is that they assume that they are smarter than HTML and extend the range of tags and attributes and constructs in the code that you can use. We call that markup sugar, because you basically sugarcoat the existing range of features that you can use in HTML with like extra stuff that they believe to be good. And it will definitely break everything in upcoming versions 2.0. Who saw the talk yesterday about AngularJS 2.0? It was an awesome talk, I really liked it. So you can see how crazy that stuff is that they're building. Like taking attribute names and wrapping in them parentheses or prefixing them with stars to do like magic in the parser. Like, what the jeez. So if you go to the AngularJS changelog and just have a look at how many breaking changes there are, you will see that there's like 92 breaking changes. Just 92. That's okay. That's easy to upgrade, right? So they don't really care if they break anything. They don't give a fuck. It's absolutely irrelevant for them if they break anything because they are after progress and not after compatibility, which might be good or not. So is it the honey boo boo of model view controller frameworks? We don't know yet. Look at honey boo boo. It's just so gross. Sorry. Like, what can I say, really? Anyhow, maybe it's not the honey boo boo of JavaScript frameworks. Because they do have fairly high security standards, but they are only good if you follow their rules. And that is only if you completely build a web application after their philosophy. If you don't do that, you're pretty much screwed. And we see people being screwed by that. We do penetration tests against people, large websites that use AngularJS, and they are vulnerable. Even Google.com was vulnerable, for fuck's sake. So on the other hand, the AngularJS people claim to be smarter than HTML. So they extend HTML with the things that they deem to be necessary, but they do that without really knowing the browser in the core. And if you fiddle around with markup and extend it and build new features, you have to know the browser they're running on, but they don't. We're going to see about that later on. So web security in itself is already a paradox. Like, there's too many layers. There's like network layer, server layer, browser layer, framework, and so on and so on. And AngularJS adds more complexity by adding layers inside a layer inside a layer. So it's like a nested layer context because there's so much complexity to style sheet parsing, to attribute parsing that they add, that it's making unnecessarily complex, and of course then things break. So on their website, they say something really smart. Pretty much the only smart thing that they say. And they say it's better to design your application in such a way that users cannot change client-side templates. For instance, do not mix client and server templates. It's fun that they say it's better to do so. They don't say you cannot do anything else but that, but they say, yeah, it's better to do so. It's just like, no, you cannot do anything else, otherwise you're going to have a problem. So you don't mix client and server templates. You don't use any user input to generate your server-side templates. You cannot ever do this. If you do this, you're screwed. You don't run user input through scope eval. Like, if you do that, you have a kind of lack of understanding how the web works, so you shouldn't do this anyway. And you should consider using CSP, which is great. But the fun part is that AngularJS bypasses CSP in itself. Who knows what CSP is? Content Security Policy. It's like a nice cross-site scripting mitigation that basically says that you cannot execute anything in that website in terms of JavaScript that is not trusted, that is not coming from a particular domain or from the domain itself or list of domains that you have whitelisted. And they kind of bypass that on their own with their magic. We're going to see about this soon. So now it's time to get nasty and to attack the framework. But given my glorious academic career, I need to add systematics. And with systematics, we start with figuring out what kind of attack surface we have here. So I decided that we need 4 different kinds of attacks. We want to attack the sandbox. Who knows what the AngularJS sandbox is? The expression sandbox. The thing that makes sure that with everything between those double curlies cannot do any bad. Of course we're going to attack that. I mean, seriously, that is the perfect attack surface. Then we are going to attack the sanitizer. So AngularJS comes with an own HTML sanitizer, claiming that it makes user input safe against cross-site scripting attacks. It's like, really? Sure. Then we're going to attack the CSP mode that it ships, and then finally, we're going to do the unethical stuff, and it's going to be attacking the code base itself. Introduce new bugs into the framework and see if the developers notice it. Let's see. A1, attacking the sandbox. So the sandbox is like some kind of weird thing that they came up with that doesn't make any sense at all, and they're completely contradictory in what they say about this. They say, for example, this is not a security tool. Don't put any user input into it. It's just to separate you from the DOM. But when you submit a bug, they instantly fix it as quickly as possible. But they still say it's not a security thing. If you talk to them about this thing, about breaking the sandbox on Twitter, they often use the term exploit. They use the term, not us. So it's kind of not making any sense. So is it a security tool or not? Well, the problem is not how the AngularJS developers perceive it, but the problem is how developers perceive it. And they see it as a security tool. So they believe it to be safe to have user input inside expressions. So we see this quite a lot, that people actually do that. And whenever we do that, we have to ask a question. Can we force the expression to execute arbitrary JavaScript instead of only the safe expressions that cannot access the DOM, cannot access the cookies and these things? And of course we can. The first bypasses were trivial because they called it sandbox without even knowing what it is. And they basically had a bug that allowed us to do constructor.constructor alert one. Who knows what this does? So we attack, or we access the constructor of the scope object, then we access the constructor of the scope object. That gives us the function constructor. The function constructor is an implicit eval. We put a string in, we execute the whole thing, so we have arbitrary JavaScript execution. Sweet. Trivial. Easy. Or of course they fixed that. So like, no, you can't do this anymore. You can't use the function constructor anymore. And it was a good fix. And then we needed to get more creative. And with version 1.2.0 and later versions, like this is the old path of actually doing this is 1.1.5. But with later versions, we had to come up with new tricks. Because we couldn't use function anymore because they blocked the access to function. They did this in a fairly good way. It looked like horrible code, but it was actually quite useful. So we had to get more creative and use properties like __proto__. Like these kinds of properties that you never work with when you have good things in mind. Like you just never touch them because they're just like bad stuff. The only people using those are attackers. And need to find a way to get around this limitation of not being able to get the function constructor anymore, or find a way that gives us the function constructor without AngularJS noticing. And that's the fun part. So the first sandbox bypasses that came after the trivial ones were found by Jan Hoare, Matthias Carlsson, and Gabo Molnar. And they used a bunch of ECMAScript 5 tricks and proto tricks and prototype tricks to kind of get access to objects that are dangerous and can execute arbitrary code. Let's have a look at these. This is one of Jan's bypasses. Jan is on my team and he does this for a hobby. So you can see here we have the double curlies just somewhere on the body. So this is being let through by every single XSS filter that exists because there's no dangerous characters in here. It's just like characters that are never being escaped or filtered. Then we take like a variable, we map a string and the sub function of the string to it, then we access the call function and the call function again, and then we call it and we override it internally via getProperty descriptor with like its own __proto, and then we access the value because we get basically a descriptor, and then we pass in a string, and then we execute the whole thing and it's done. So this is still trivial. It's still fairly simple and understandable. So they fixed that. Of course they fixed that. So we had to work around this. This was my variation working in 1.2.18 and also working in 1.2.0 because there was like another protection in there that we needed to kind of get around. So heavily inspired by Jan's bypass, I took a string that I fed with a value constructor, then I took like an empty object, and then was calling call. Then I realized that I couldn't use __proto because they were banning that already. So I said like, okay, you cannot use __proto__. Well, then I don't. Then I just use getPrototype off from ECMAScript 5, and then I get my proto back. And that was basically it, so bypassed again. And then they fixed that. And we're like, damn it, they fixed it again. Then Matthias Carlsson came up and had like an awesome bypass. So he said like, let's take the scope object and let's take toString and the constructor of toString and then the prototype of the constructor of toString and then again toString and then assign toString constructor prototype call. So he just overrides toString for everything that is out there with call. So now toString is equals call. And it's like, oh shit. And then you take an array that is filled with 2 elements, an empty string, or like a useless string here, just the string A, and then a string that says alert1. And then we call the sort method, which is allowing us to use a callback. And guess what that callback is? Well, it's the constructor of toString, and toString is deemed to be safe, only it's not because it's now call. Bam, you have a bypass. Still trivial. Here's Gabor's bypass, after they fixed that one for 1.3.0. That's pretty fucking awesome, because he was the first one to not attack JavaScript or use JavaScript directly for an attack, but to attack their internal parser. So as you can see, he uses the $$ watchers and just like does something with this kind of post-digestion feature that they have internally to kind of infect AngularJS by using an expression and mess up with the core of the framework. So he's not even using JavaScript magic anymore, he's just like breaking the framework in itself, the shortcomings of the parser. And again, we have the alert, and it pops, and then they fixed it. Damn it. There was another possibility we could use to create arbitrary JavaScript execution. We, for example, realized that we also have the possibility to use ng-focus or ng-click as an attribute if we have an HTML injection. And then we just access the $event object that is being provided. And the $event object is mapping to the actual click event or the actual focus event. And guess what is being exposed in the view object? It's window. So we have window, location, replace, JavaScript document write, and there we go. So another full-blown bypass. But they fixed it. And, well, we found more bypasses, they fixed them. We found more bypasses, they fixed them again. And eventually it got weird. Because one of the recent bypasses that Jan developed was this motherfucker. So I'm not going to go through all the details and explain this thing, but we can talk after the presentation if you want to understand it. It took me half an hour to understand it. And I'm not sure if I fully understood it, but you need like 2 expressions, and then you like map everything around inside the framework core, and then just something happens. If you're interested in how this works, just like chat me up after the presentation. And they fixed it. So meanwhile, their sandbox is so restrictive that nothing is possible anymore. You cannot access window, you cannot access function, you cannot access object, you cannot access call, you cannot access proto, you cannot access prototype, you cannot access document, you cannot access DOM nodes, nothing at all. And you might think like, hey, we have a secure sandbox now, right? With enough crossfire from all sides, this thing finally got strong. Is that the end of the road? No, it's not, of course not. This one was found by Jan again. So you take a number, and then you do like this trick with the double array. So you have like an array, and inside the array is another array, and that is pointing to the actual __ proto, because that bypassed the proto check. Because it's like, hey, it's the accessor __ proto, and it would say, no, it's an array. But in reality, for the engine, it's of course proto, so bypassed. He again overrides toString with something else. They have like this kind of internal stringification of Boolean and number values, and then he was just like passing the input into root eval, interrupting the string, doing stuff here, and then having another sandbox bypass. So they fixed that, and then came Gareth Ace from the UK. And he said like, yeah, those bypasses with all the internal property overriding, they're like quite nice, but I think we can attack this far more trivially, and he did. So he basically said, like, okay, in the scope we have $eval. And $eval does a lot of operations. And one of these operations is using char_add to have a look at critical characters to encode. So let's just override char_add with array join. And then it doesn't check anymore, it just concats, and that's it. You can even memorize this and just like use it whenever you want. It's just like a string, constructor, prototype, char_add equals array join, and that's it. That's all you have to do. Working in all versions, except for the very latest. And, well, you can see this is kind of an arms race, and calling this thing sandbox doesn't make any sense because it ain't. And in the latest version, I found another sandbox bypass that is inspired by Gareth ones, because they fixed it in a way that was like really horrible. Can you see the bug? The bug is in here, because this is the method that they added to fix Gareth's bypass. It's like so bad. If you look at this, it's like really, oh God. So what they do now is they check whether you are currently assigning to constructor. Well, I'm not going to tell you how to bypass this, but you can chat me up later and tell me what you think, how you can bypass this. It's actually quite easy. And I was mocking them on Twitter and say like, another bypass in the latest version 1.5.0 RC2. And then the maintainer was like, yeah, can you give us the bypass? And said, no, because it doesn't make any sense. We need to stop that arms race. Like, just like, let's leave one there because you're not going to fix it anyway. And then it turned out that he talked to me. It's like, yeah, you know, actually it's not maintained by Google anymore, and I'm not from Google. So I'm just a bloke in London. I'm a freelancer, and I'm maintaining the 1.x now. I'm the tech lead for 1.x. It's like, okay. So let me explain you why I don't want to share this bypass. It's like, okay, explain it to me. And I explained it to him. It was a bit complicated, but then he realized that I'm right, and then it doesn't make any sense to kind of engage those arms race anymore. The last fix required them 120 days, and I think the fix for this one would again take them 120 days, and they don't have any resources anymore. So security bugs in AngularJS 1.x are not being fixed anymore. And, well, I can kind of understand that. We should be talking about this later on. I don't want to waste too much time on attack 1. There is one more that is quite funny. I really like copy-paste based attacks. Like you copy something and then something completely different comes out. And this was my approach of attacking that. You basically overwrite the default properties of the event that is being emitted and then overwrite the clipboard using the new clipboard API, and then you have an SVG in there that upon pasting somewhere is going to unfold and then execute JavaScript, so that also works. But you don't have the possibility to use this quite often. It's just like to prove that this is working as well. So the sandbox is pretty much not a sandbox, and we attacked it and now it's down. It's not doing anything anymore. So that's not good. There's Honey Boo Boo again. Let's talk about A2, attacking the sanitizer. So as mentioned, they have a sanitizer, and the sanitizer is capable, or claims to be capable, of sanitizing HTML. So you pass a string in, you get a string out, and then the string is clean and everything's fine, and you can work with it, and no XSS will happen. Not so much. So the funny thing with the sanitizer is that there's two of them. There's an old sanitizer and there's a new sanitizer, and they recently replaced it. The old sanitizer was based on an HTML parser that they borrowed from John Rassick. Like this old crappy thing that he wrote in 2008. They used this in AngularJS, and it worked quite well for quite some time. It was extremely unstable, crashing all the time, but it worked. And of course, this thing could be bypassed. The bypass was trivial again. So what you would do is you would use an SVG. And inside this SVG, they forgot that the use element is quite evil. And with the use element, you were pointing to a resource that, independently of the content type, is going to give you something JavaScriptish or HTML-ish. So, for example, an insecure JSON callback that you could never really exploit, but in this particular situation, you can. So inside this callback, you would get another HTML element. It would not be going through the sanitizer, just being referenced by the use tag, then being imported into the actual page, and execute JavaScript. You can try it out. There's like the URL up there, and you can just like type it in and test it with Chrome. Then they started to install a new sanitizer, and that wasn't as weird as this 2008 thing that they used before, because they actually started to use document.implementation, a strategy that we're also following with DOM Purify. And they also prohibited the use of SVGs because they realized, oh, SVGs, they are like, we didn't see that coming. They're like so bad. Like there was no research at all. And we had to look at the new sanitizer as well. Even for Google, it was like a contracted work. And we realized that even this one was bypassable. Only in Chrome again. Because in Chrome, there is like a funny artifact. If you have a URL, and if you have a link, an anchor, and you have an href attribute, and after the href attribute, you have a Unicode whitespace, then if you just type it into the document, it's not going to do anything. So you can click it, and it's like indeed a relative URL pointing to a server resource. But if you first take it, and then map it to another inner HTML property, and that is what the framework does, then the browser transparently strips the Unicode whitespace, and what remains is a JavaScript URI, and you have another XSS. So even that didn't work. And you could use almost arbitrary Unicode whitespace characters, this one, or this one, or this one, or this one. If you have a look at the DOM Purify sources, you will notice that this is why we kind of filter these characters, because they're pretty bad, at least in Chrome. And I don't see any intent for them, of theirs to fix it. So this also didn't work. Like the next security feature that they're offering was broken as well, and there is no fixes in sight, because now it's like end of life for 1.x. So let's talk about CSP. Now it's getting fun. Because as mentioned, in CSP, you have the possibility to whitelist the resources that can execute JavaScript and do other things on your page and make sure that injections don't work anymore. One core feature of CSP is that if you set it up right, then you cannot use inline event handlers anymore. There is no more on-click, there is no more on-load or on whatever. It doesn't exist anymore. The browser will reject to execute it. That's a great thing. There's also no eval anymore. There's no function constructor anymore. All these things are gone with CSP. So if someone injects like a body on-click something into your website, it won't execute because the browser says like, nope, CSP is on. I'm not going to execute that. You have to do it differently. So this is great. And CSP in itself is great, and it's an amazing security tool, hard to deploy, but still very, very thorough and very well designed. And they were like, wait a second, we just like saw a bunch of slides ago that they have their own event handlers, right? Because they're smart, and they said like, no, we need definitely our own event handlers. That's like the most important thing. And that they came up with things like ng minus click. And it's like, okay, this means there's a bypass. Because we can, again, use inline JavaScript, only it's not inline, but it's made to be inline by AngularJS. So what we did in the past was just like inject onClick alert 1 into a website, then CSP came, blocked that. And what we do today is just like inject ng minus click equals $event $view alert 1, and that's it. CSP is fully bypassed. Full access to the window object, full access to cookies. CSP delivers no protection just because AngularJS is there. Well, of course, they fixed that. We had a closer look at that and realized that you cannot just like, for example, use ng minus click. You can do this, and you can use ng : click, and x minus ng minus click, and data minus ng minus click, and you can even do that. It's like, what? Who came up with that crap? Well, the point is that they actually normalize all ng attributes and throw out characters that no one needs. So you can put whatever in you, it's like still working. It's like, really? Oh my god. Anyhow, this worked until 1.1.5, and then they fixed it. However, there's new bypasses, and they're pretty neat, because for a long time it was a theoretical bypass, with the foundation being ECMAScript 6, AngularJS, and a small Chrome bug. So AngularJS has the possibility to introduce ng minus click and whatever. In Chrome, when we have a CSP-protected page, and from that CSP-protected page we open another document that is coming from a blob URI, then this does not have CSP headers anymore. They're gone then, because of, I don't know, reasons. But you enter a domain context that is on the same domain, but no CSP. Now the question is, how do we get there? How do we get a redirect on a blob URI? This is impossible. And the first that comes to mind is just like create a blob by using the new operator. But the AngularJS expression parser doesn't allow using new, so we had to find a way around that. Do you know a way around using the new operator if you want to construct something? Well, there's ECMAScript 6, and there is the reflect API, because there you can do it programmatically. And you can say reflect.construct as a function call, and you don't have to use the new operator anymore. So this is the bypass, and it's pretty sweet. It's a bit hard to read in this particular representation, so let's maybe have a look at a nicer to read representation, and let's read from the bottom to the top. Here, we build a blob, and we fill that blob with some nasty HTML. We give it the right content type, and then we take that blob and we throw it into event.view.reflect.construct, because that gets us around the limitation of not being able to use the new operator, which AngularJS would forbid. This works. Then we say event.view.url.createObjectURL with that blob that we just constructed, and then we take the whole thing and say event.view.location.replace and throw the blob URL in, and then we have a full-blown XSS. Because no CSP on blob, no new operator needed to create the blob, create a URL from that, redirect to that URL, and done you are. So that was nasty as well, and there is no fix as well. So I even do not really know how they would want to fix it, because they would have to block reflect or something like this. Anyhow, they did some patches to this in later versions, but they weren't working too well. So again, we can say AngularJS is actively bypassing CSP. Don't use AngularJS and CSP at the same time, because then you don't need CSP. It's pointless then. But it's getting much better. And this is so bad. This is like so bad. So we were confronted with a situation of a client's website that had good CSP rules and was using the latest version of AngularJS. And we're like, God damn it, we have the injection, we want to kind of pop the code here. And we couldn't figure out how. And then I had to look at the CSP headers and saw that they did a terrible mistake that no one should ever do, because they were using a CDN. Don't use CDNs, because they're your misery. Or don't combine CSP with CDNs. So the CDN that they were using was the ajax.googleapis.com. This CDN gives you tons of JavaScript libraries, new ones and old ones. And the question that popped up was like, okay, if we have very new AngularJS on the page, and they whitelist ajax.googleapis.com, can we just not reinstall a very old version of AngularJS and overwrite the existing one? And then you might say like, no, you're entering a race condition, because the newer one is bigger and takes longer to load, and the older one is smaller and just shorter to load. So even if you inject the older one after the newer one, it's going to be loaded first, and then the newer one is being loaded and then overwriting the older one, so that wouldn't work. Well, that's not true. Because the buffoons of AngularJS decided to build in a collision check, but only after a certain version. So only after version 1.2.15, AngularJS will say, oh, there is another AngularJS already. I'm backing off. I'm doing an early return. Bye-bye. It's like, what? Seriously? That's like the worst thing you can do because you create an unfixable bug. That means that old versions of AngularJS will always win, independently of when they load. They will always win because the newer ones have a collision check. The newer ones, the safe ones, will always back off. It's like, oh, there is an older one already. So bye-bye. And it looks like this. You have strong CSP. You fetch AngularJS in the latest version from the CDN, and the injection is just like that. Closing the attribute, injecting a script element, pointing to the API, fetching an ancient version, then saying, okay, h1, headline, or whatever element, then ng-click, event view alert 1, and there the old bypass is back. And there's nothing you can do about that. We had like a long video conference with Google about this, and they were like, this is hard to fix. And yeah, that's hard to fix. You fucked that one up. And there is no easy solution. Like seriously, this was just bad practice. So if you have a high security site, don't use the Google CDN. We made like a challenge because I wanted to find out how many people know about this trick, and I called the challenge "Shit, it's CSP." So you had a website with CDN, and you could inject, and an awful amount of people found out about this, and they found even more terrible things in the Google CDN, like vulnerable flash files, vulnerable feed reader APIs, like horrible stuff, and they all could be used to bypass CSP. So the third security assumption is broken. First one was sandbox, second one was sanitizer, third one was CSP, all broken, and all actively broken by AngularJS. Not passively, not like accidentally, actively. And they know about that stuff. So if they can play dirty, we can too, right? Let's attack them. So in an open source repository with a lot of traction, attackers might be trying to sneak in pull requests that are not nice. They might be trying to find issues that if they report them the right way, get fixed in a way that the attacker gets a fresh bug as the result. We were like, we should try that. So of course this is nothing that you just like try without asking anyone. So we asked Google Security and said, hey guys, we have this plan, we want to be really nasty, and we want to introduce a bug into the AngularJS code base and see if they notice. And they were like, really? Do you have to? It's like, I would really want to try. It's like, okay, do it. That was in November 2014. And I found that particular bug late December 2014. And I constructed the case so my fix would actually introduce a new bug. It was a bit of work. And then I submitted that bug. And I was waiting. I was just like sitting there and waiting. And one day I received an email that was mid-January 2015. And it was from GitHub. I mean, it was from one of the maintainers of AngularJS on GitHub. He saw my bug and said, like, hey, that's a cool bug. Thank you, man. We're going to fix that. Yes. And this is the bug. Just 1 second. Here we go. They have the sanitizer, as mentioned. And the sanitizer is used for pretty much everything, also expressions. So it's not only if a website uses sanitize actively, it's also used implicitly by any expression that is being echoed. And I noticed that in the array, or actually it's a map, in the map of whitelisted attributes, there's 2 attributes that are phishing that can be used for cross-site scripting. So they're whitelisted already. So the assumption is, hey, we have a bug already. We don't even have to introduce a new bug because this is already buggy. But the problem was, when I tested this and wanted to kind of conduct XSS by using these 2 attributes, you're going to see in a sec how we can do this, then they didn't get accepted, despite being on the whitelist. And I said, that's strange. Let's have a look at this kind of thing. And I had a look at the code, and I had a look at the attribute parser that they use in the sanitizer. And I realized that each and every attribute that is incoming is first being lowercased. But the original attribute name is not being lowercased. And that's fine with HTML, because in HTML, you don't have mixed cases. You don't have camel case or something like this. This doesn't exist in the world of HTML, but it does exist in the world of SVG. Because there we have attribute name and attribute type, and there are camel case. There's a bunch of more camel case attributes in SVG, but those are the sexy ones, because they give us cross-site scripting. So they destroyed their own whitelist by doing this lowercase operation. And there I was saying, like, there's like a bug in your whitelist, because you're like kind of lowercasing everything, and whitelisted stuff is not coming through. Could you fix that, please? And they were like, yeah, we're going to fix that. Thank you for finding that bug. So yes, cross-site scripting. So I drafted that carefully and made sure that they don't know who I am and what my background is and whatnot, and told them to fix that bug, and then they fixed it. So they accepted this thing. You can follow the entire story here if you click that link, if you have internet again and access to the slides, and you can see how the discussion was. And actually, you can also see how fucking easy it was. It was not really hard to get this thing in. So this was the bypass, and was giving me cross-site scripting on google.com, on countless other pages. Like everybody who was using expressions or the sanitizer, like literally every page that is using AngularJS could be abused with this trick. So the only thing that had to be done was take an SVG, and inside this SVG we take a link, an anchor element, and then we take this anchor element, we give it like a super harmless href attribute that you can see here, it's just a question mark, and then inside this anchor element we use a circle, so we have something to click on with a big radius of 400 whatever units, and then inside this also we use an animate element. Who knows what the animate element does? Well, it animates descriptively a chosen attribute of the parent element. So if you have like a red circle, you can animate it to be green if you feel like it over the course of a second or hour or whatever you want to go with. But you cannot only animate colors or dimensions or positions or paths, you can also animate href attributes. So you can animate links. Like, what came up with that idea? So animated links, the next big thing. Like, what are you using? I'm using animated links. And what we do here is we don't directly animate it from the harmless link to a bad link, specifically the JavaScript URI. But we use a small trick, because that wouldn't work. We couldn't animate it directly. But what we can do is we can go ahead and say, like, we animate it to an ampersand. Now, what would that do? Animating something to an ampersand, an attribute. And something that is technically XML, because that's what SVG is. It will throw an error because ampersand is illegal, because it introduces an entity, but it never completes the entity. So it will go, say like, hey, the original href is question mark, and the future href is gonna be ampersand, so let's animate that. Oh, wait a second, I have to go back to the original state. Wait, what was it? Oh, it was the from attribute. That's the bypass. Firefox did it. Chrome did it. I think Chrome doesn't do it anymore. I'm not entirely sure. Maybe they still do it, and Firefox definitely still does it. Internet Explorer or Edge don't do it because they don't implement animate and set, like those two critical elements. It's actually quite funny because SVG is like a melange of PGML, Precision Graphics Markup Language, and VML, and W3C wanted to create like a new standard that is uniting the both, or taking the best pieces of both, and PGML was like 90% of SVG, or 95 even so, and VML, a horrible language by Microsoft, is the remaining 5%, and the SVG implementation in Internet Explorer does not support the 5% that Microsoft contributed, which is kind of gets you to think. They know exactly there was a really bad idea, but this kind of pities back. Yeah, anyhow, so there was a bypass, and it worked. So I reported the issue to Google Security instantly. They were kind of waiting for this already. And they informed the AngularJS team, because we didn't really have good grounds to communicate with the AngularJS team anymore. This is like, these bridges have been burnt, and nothing happened. And it went from the early betas to the first release candidate and to the second release candidate, and still the bug was in. It's like, guys, you have to fix this. I mean, we're attackers, but we still have a spark of ethics in ourselves, so you have to really fix this. It's getting closer. And we pinged them again and again and again, and eventually they actually fixed it. It was like super close to the release. It's like, whew, that was a ride. And the experiment was successful. We managed to kind of introduce bad code into a very commonly used library, and no one noticed. And had we not told them, they would have never noticed. We would have had universal access on pretty much any website out there that is using AngularJS. So since then, they added comments because they were so angry at us that they said, like, okay, we're going to do something. And they added this comment that basically obligates anyone who's doing changes on those files to have a review from at least 2 core members. So that's a good thing, right? I mean, they did something good here. And no one can touch this anymore, because now they know that there's bad people out there that do bad things. And not everybody liked us for that, for pulling that one off. And not everybody was like super happy. And well, we even got bug bounty for that in the end. So I think it was like $1,300 or something like this, but we even got money for that in the end. So deal with it. It's time for a conclusion. Over there, they're already clapping. I do believe that AngularJS 1.x, so the thing that pretty much everybody's using, is dramatically increasing the attack surface, especially when you put it on top of websites that still follow the old pattern of accepting get parameters or rendering user input from the server. They do a lot of things right, so I'm not here to just like constantly blame AngularJS. They do a lot of things right, and they have amazing ideas and extremely creative ideas, and I think they really contributed to websites having less code, being nicer to author, complex websites that can be written and created with few lines of code, and that's a good thing. But what I don't really like is the fact that they completely neglect security. This like doesn't exist in our world. There's not a single CVE. There was not a single credit ever. We never got credited for our fines, even the ones that we reported nicely, because eventually we stopped reporting nicely. Never was there any form of credit. We never kind of received any bug bounty except for this one stunt with the rogue commit. And in addition, next to completely rejecting security as a topic for themselves, they make it hard for people to upgrade. So they completely killed the thought on compatibility. So there are so many websites out there that still have vulnerable versions. We don't even have to use those fancy tricks because most of the cheap tricks are still working. There's a guy in Norway, a good friend of mine, he did some work on that, and he found out how many websites in Norway are still running ancient AngularJS versions, and it's horrible. It's so many. It's like the majority of websites out there use outdated, insecure versions. Google security team did really, really well. They allowed us to pull off this stunt, and they supported this thing, and everything was done by the book. It was really, really good. And the only thing that I believe needs to get better is just like Google getting back to documenting things like they did in the past with DocBook and Browser Security Handbook, and telling developers about those pitfalls. Because where else are you going to find out about them? And where can you learn how to do things right and not shoot yourself in the foot? And that is something that I believe is missing. There is no good documentation that tells you this is the way to go, otherwise this is going to happen, and there's going to be an access session that's going to suck for you and your users. So that's it. That's my presentation. I hope you have any questions. There's a lot of shouts that I have to issue. One to Gareth Hayes, one to Jan Horn from my team, Matthias Carlsson for the bypasses, Gabor Molnar, David Ross, Eduardo Vela of Google Security, and of course the entire AngularJS team for giving us so much access. Thank you so much. That's it. Thank you.
Thank you. I'm afraid we already ran out of time, and I was told that we really have to end on time, but maybe you can stick around in the break for some questions.
Yep.
So thank you for this talk, and we also have some Linzer Torte for you.
Thank you very much.
Thank you.